present filler table question 1 part A, facts and ideas. So for facts, the number of bacteria observed to grow at the rate proportional at the number of cells present. There are 10,000 cells at the beginning. After 3 hours, they increase to 500,000 cells. And we need to determine the number of cells after 24 hours, and then that will be years. So for the ideas, we apply exponential growth equation, which y equal to a b power of x, that it takes the growth rate proportionally to the amount of bacteria cells. And number 2, 10,000 cells is the constant value. For the initial value, we determine its growth rate. By using a simple rate determination method, we can easily find the bacteria growth rate value constantly by simply dividing the number of cells growth. Number 4, we have insert the related values into the equation to solve the problems. Number 5, we need to derive the original equation to determine the value. So that's all from me. Thank you.
My name is Ainatul Fasha binti Ahmad. I will continue to the filler table part A and filler table part B. I will explain to the learning issue and action plan. For the learning issue, the question we got from the problem statement. So first, why the number of bacteria increase? Number 2, how many of cells will there after 1 day of growth? And number 3, what is the adopting time of the bacteria? And number 4, if unlimited growth continues, how many cells will be there? For the action plan, we get initiative from this questionnaire. First, make a group discussions for share the information with each other. And number 2, find information about growth and population. Find to the such as from book, internet, or other medias. And number 3, refer for similar methods online, such as from the website if the equation is similar to with this problem. And number 4, each member will assign to find the best way to analyze the growth rate equation and to solve both problems.
Hi, I'm Sarah. I'm going to present about problem for part A. So the number of bacteria in a liquid culture is observed to grow at a rate proportional to the number of cells present. At the beginning of the experiment, there are 10,000 cells, and after 3 hours, there are 500,000. The question is, how many will there after 1 day of growth if this unlimited growth continue? Second question is, find the doubling time of the bacteria.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Miftah Akif, and now I will be discussing the solution for our problem. So as stated earlier, this is our problem, and now let's go to the solution equation. First, our solution would be using the exponential growth equation, which is y equals to a bracket b to the power of x, where y is the final value and x is the time taken, b is the growth rate, and a is the initial value of the product. Since the question states that it multiplies to about 500,000 after 3 hours, so we can get that it is multiplied by 50 times after 3 hours. So we got an initial value of a, which is 10,000 stated in the question, and b equals 500,000 divided by 10,000 to find the growth rate. And since it took about 3 hours to reach that number, we divided by 1/3 to find a value for 1 hour, and t is time taken that we will put later in our equation. Okay, now that we have all of the values needed, our growth equation will be this, which is y equals to 10,000 times 50 to the power of 1/3 t. Okay, let's try to solve the first question, which is a. How many will be there after 1 day of growth if this unlimited growth continues? Okay, first we need to change the units from day to hours. So 1 day is equals to 24 hours, and we can directly insert inside this equation. As you can see, y equals to 10,000 times 50 times 1/3 times times 24, and the final answer would be 3.906 times 10 to the power of 17 cells after 1 day. Next, we'll go through the solution for question B, which is to find the doubling time of the bacteria. In this case, the final value will be the initial value times 2, which is 20,000. So we technically got y, which is the final value, which is 20,000, and we insert the original equation here. Now we need to find the value of t, which is the time taken, and from this we just move 10,000 to here and becomes divide, and the answer will become 2. On the side we got 50 power of 1 over 3t. We can apply logarithm to both of this, and with a logarithm law you know that the power can be moved to the front, and then we just simply divided both of this and we move t to the side. So after this we derive and put bring t on the side, so we got 2 divided by log 50 divided by 1 over 3, and we got 0.53 hours times 60 minutes to make the equation easier. So t time taken for the doubling method is around 31.8 minutes. So therefore the doubling time of the bacteria cells is around 31.8 minutes or 0.53 hours to double from, let's say, 10,000 to 20,000 or 20,000 to 40,000. That's all for me. Thank you very much.
For discussion and conclusion, we can conclude that the growth of bacterial culture is defined as an increase in the number of bacteria in a population and based on the size of individual cell. Bacterial population grow either geometrically or exponentially. Basically, one cell increasing by 2. For example, one cell gives rise to 2 cells, then 4, and so on. By using the exponential formula, there will be around 3.906 exponential of 17 bacteria cells after 1 day of growth if this unlimited growth continues. Also that the doubling time is 31.8 minutes.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Miftah Al-Aqib bin Muhammad Zahir. My metric number is 88191808, and now I'm going to discuss the Phyla table for part B. Without further ado, let's begin. So as we all know, Phyla tables are separated into 4 parts, which is facts, ideas, learning issues, action plan, or resources needed. So without further ado, let's begin with our first fact, which is here. Room temperature is 20 degrees Celsius. Number 2, the body temperature is at 32 degrees Celsius. Number 3, the temperature of the body falls down to 30 degrees Celsius after 2 hours. And finally, when the murder occurred, the temperature of the victim body is at 37 degrees Celsius. Now let's look at the ideas. Number 1, let the variable T represent the temperature of the body. And number 2, 20 degrees Celsius is the constant room temperature. Number 3, the temperature of the body when the murder is occurred is 37 degrees Celsius, since that is the normal human temperature. And number 4, find how many hours and times are before or after 9 AM of the death. And number 5, find the time of death. So let's look at the learning issues, which there are 3. Number 1, what is the temperature when the murder occurred? Number 2, what is the time of death? Number 3, when is the murder committed? So let's look at the action or resources we use to solve this problem. Number 1, we discuss with a group member to solve the problem. And number 2, we identify the solution and refer the module of Engineering Mathematics 2 from the UTHM library. And finally, we all finish the assignments before the deadline. So that's all for me. Thank you very much.
Okay, for the Phyla table part B, which is the title is Newton's law of cooling that related to the temperature, and the time. For the learning issue, the questionnaire we got from the problem statement is first, what is the temperature when the murder occurred? Number 2, what is the time of death? Number 3, when is the murder committed? For the questionnaire, we got the initiative. First, discuss with group member to solve the problem. it seems like to the filler table part A, to share information to each other. And number 2, identify the solution, refer to the module of engineering mathematics. 2, find the formula, to know the step of calculation. Number 3, finish the assignment before the deadline. So we got to improve our mathematics problems.
Problem is, a detective finds a murder victim at 9 in the morning in a room that is kept a constant temperature. The temperature of the body is measured to be 32 degrees Celsius. 2 hours later, the temperature of the body cools to 30 degrees Celsius. Assuming that the body temperature of the victim when the murder occurred is 37 degrees Celsius, and what time did the murder occur?
Yeah, we present about solution of calculation part B, Newton's law of cooling, question 8. First of all, I let variable T represent temperature of body, and then I did the differential equation of Newton's law for the temperature for the body, and then I put temperature all together and the others I put this side, and we need to integrate both sides, and then this one we will get. From the integrate, we will get equation T equal to 20 plus CE negative KT. So first of all, we need to find C with using this one, 9 AM, which is 3T time equal to 0, and then the temperature equal to 32 degrees Celsius. Then we put the temperature into this equation, and then we will get C equal to 12, and then we will get the new equation, which is 20 plus 12E negative KT. We will find K. So using this one, 2 hours, time equal to 2 hours, and then the temperature 30 degrees Celsius. So we put 30 degrees Celsius into this equation, into the new equation, and then we will get K equal to 0.183. And then we put this value K into this equation, and then using this equation, we will find time for the murder. So we assume the body temperature of the victim when the murder happened is 37 degrees Celsius. So we put this temperature into the new equation. So we will get T equal to negative 1.07 hours. So for this one it's 1 hour, and for this one we don't know how many minutes, so we need to convert to minute, which is which is times 60 minutes. Then we will get 54 minutes. So for the time is negative 1 hour plus 54 minutes. So we need to find the time of that, which is 9 AM. The initial one, so 9 AM minus 1 hour 54 minutes, we will get 7:06 AM. So the murder time is around 7:06 PM. So that's all for me. Thank you.
Next, I'm going to present about discussion and conclusion. So in this project, we learn how to calculate the time taken for the murder occur. And this project requires us to think the solution to solve the problems. And we have utilized the Newton law of cooling in this problem to find the rate of heat loss from the body proportional to its excess over the surroundings. Lastly, we managed to incorporate this value to the heat formula and determine that the murder time occurred at around 7:06 AM.